is abrasive blast cleaning. A stream of abrasive, air-propelled at high speed against a surface being cleaned or prepared for coating. During the past 60 years, there has been continuous progress in improving abrasive blast cleaning until today it stands alone. There is no better way to prepare a surface. Reference through the movie will be to sandblasting. However, this term will encompass all types of abrasive blast cleaning with silica sand, mineral grit, steel grit, walnut shell, and so forth. Sandblasting is used in cleaning bridges. Either kind. Sandblasting is used to cut names and dates into headstones. It can etch glass, such as shower doors or mirrors. It is used exclusively to prepare ships' hulls and tanks for coating, where positive bonding of the surface coating is required so that corrosion will be held to a minimum for years of sea duty. Sandblasting protects the huge investment we have in our industrial plants and factories. Of course, there are other methods of cleaning a surface. On the left, wire brushing. In the center, flame cleaning. To the right, sandblasting. It is apparent that these other methods are much slower and less thorough. The sandblasted surface will extend the life of any protective coating. An analysis in the Steel Structures Painting Manual shows that a sandblasted coated surface will hold its finish 4 times as long as a wire-brushed surface similarly coated. The reason can be stated in 2 words. Anchor pattern. Sandblasting gives the surface a tooth that anchors the coating, which is essential with any of the modern coatings. This movie will show the many items of equipment that produce a low-cost, high-efficiency sandblasting operation. Lack of attention to any one of these components can wipe out the entire effort. Imagine baking a cake without using all of the proper ingredients. The result is far from satisfactory. Remember, lack of attention to any one of these components can wipe out the entire effort. The components of a sandblast system are an air compressor, a Bull airline, automatic remote control valves for cost savings and safety, a lightweight, portable, high-production sandblast machine, an abrasive metering valve, quick external couplings for the sandblast hose, static dissipating sandblast hose, long-life Venturi nozzle, and an air-fed helmet for the comfort and safety of the blaster. Let's consider these components one by one. First, the air compressor. On the right is an old-style piston-type low-volume compressor. On the left is a newer, high-volume rotary type. The large one has ample capacity for efficient operation, since it will maintain a constant high pressure hour after hour. The air compressor is the most important component in an efficient sandblasting system. Work will be done in direct proportion to the volume and pressure maintained at the nozzle. A large compressor permits the use of larger nozzles. To utilize the larger air capacity, big airlines are needed. 1.5 to 2 inch ensure proper pressure at the nozzle. Many blasters use small 1/2 inch and 3/4 inch airlines. Friction losses in these small lines may cut nozzle pressure by 50%. Shown on the left is a high production sandblast machine. Also shown are 2 models similar to those used for years. The quick-filling concave head on the green machine fills rapidly, and the blaster, Speedy Gonzalez, is ready to go to work again. He doesn't really need a pot tender at all. Brand X, with its small opening and manually operated filling valve, is slower, while Brand Double X needs a funnel and patience, a strong back, and a whisk broom. Clothing courtesy of the supplier's name withheld at his own request. In the concave head of the modern machine, there is an automatic filling valve. It opens when the pressure's off and closes when it's on. This machine has remote control valves, which can be installed on all sandblast machines. These remote valves provide 100% safety to the blaster. The blaster can then start or stop the blasting at the nozzle. Should he drop the hose while blasting, the unit instantly stops. This is particularly important when doing work inside tanks. The air entering the pot from the compressor pushes the valve upward against the rubber seal around the hole in the concave head. Used with the automatic remote controls, this automatic filling valve saves a lot of time. This is particularly true when you top the machine with a hopper full of abrasive. A day's supply of sand is held in the hopper and will flow down to fill the pot without need for a pot tender whenever the automatic valve is allowed to open. And since sand reposes at a 32-degree angle, it will not overfill. This is practical automation, a big saving in time, in labor, and in money. Sandblasting machines should include a water trap to separate out the moisture and prevent clogging of the abrasive. The real heart of the machine is the sand control valve. It must be adjustable to match the flow of abrasive to the size of the nozzle, the air pressure, and the job to be done. It must meter out a steady flow of abrasive hour after hour with no change in rate. This sand miser valve fills these requirements. As you can see in this cutaway view, it is ruggedly built. The orifice plates are of tough stainless steel. Now, watch what happens when the valve is open. The one on the left matches the one on the right. With the valve partway open, the sand flows at a steady rate. And then, as the orifice is opened still wider, the flow is increased and steady as an hourglass. This is vitally important for good work. Many users continue to use excessive amounts of abrasive because of poor control valves such as gas cocks. Savings up to 60% have been reported. Ask any blaster what an irregular flow of sand will do to his work. He'll tell you. It will increase the efficiency of even the oldest pots and can be easily installed on almost any machine. Another requirement for a really efficient sand control valve is a means of quick and easy cleanout. If some foreign object plugs the valve, sand miser cleanout means a downtime of only 2 or 3 minutes, as against 40 minutes to 2 hours with other valves. Here's one good reason why you should use standard, carefully screened abrasive. Sandblast hose is an important part of balanced equipment. It should be 1.25 ID for least friction loss. The whip should be no less than 3/4 inch, and preferably 1 inch ID. Sandblast hose should be of the static dissipating type to eliminate electrical shock to the blaster. The shock itself would not injure the man, but the drop from the scaffold might cause a slight personnel shortage. The sandblast coupling below is one of the old-style internal types requiring a wrench. A disadvantage of the internal coupling is the fact that it restricts the flow of air and abrasive. There is turbulence, congestion, and wear at this point. This is not true with the externally fitted quick couplings, where there is no internal obstruction. With quick couplings above in this picture, just a twist will couple or uncouple 2 lengths. The ease and speed of coupling and uncoupling sandblast hose ensures the proper lengths of hose for the job. Nozzles are the smallest piece of equipment, yet one of the biggest in importance. In 1900, we had ceramic nozzles costing 35 to 50 cents and lasting only 1 or 2 hours. A few people used the then expensive cast iron nozzles. They ran as high as $1 and lasted all day. Almost. 40 years later, tungsten carbide came into the picture. It boosted the price, but it also boosted the life expectancy quite a bit too. Then, in 1954, the breakthrough came. The Venturi nozzle was put on the market. It doubled the speed of the abrasive with the same pressure and increased the efficiency of the whole operation by as much as 30%. In 1958, the Norby Venturi was developed. This has tripled the nozzle life. So today, it costs less per hour for a nozzle than it did when they only lasted an hour or 2. Not only that, the Venturi has increased production because the greater the velocity at the nozzle, the faster the abrading action. Nozzles are made in many sizes and shapes. Users should obtain a selection of sizes to fit specific jobs. Finally, efficiency in production depends on the comfort and the safety of the blaster. The protective helmet is a must, and it should be air-fed to keep dust out of the helmet and to give the blaster plenty of clean breathing air. Now, we're going to run some of the standard blasting tests for the camera. Using 3 identical machines and accessories, except for one thing. The pressure at each nozzle is different. On the left, 60 pounds pressure. In the middle, 80 pounds pressure. On the right, 100 pounds pressure. All tests shown are on rusted old steel plates with mill scale. And notice that the proper nozzle blasting angle is 80 to 90 degrees to the surface. It's clear that adequate pressure at the nozzle makes all the difference. 60 pounds pressure cleans only half the area cleaned at the 100 pounds pressure. The 80 pounds pressure cleans only 2/3 the area cleaned at 100 pounds pressure. Or 100 pounds nozzle pressure will clean twice as much as 60 pounds. That's quite a difference. Now, let's conduct another test, this time showing the advantages of a larger nozzle. In this test, the pressure is the same on all nozzles, 100 pounds pressure, but the nozzle orifices are different. 1/4 inch, 5/16 inch, and 3/8 inch. All are Venturi style. Here, the man with the larger orifice nozzle gets the job done in much less time. The difference is plain. Recall that all 3 men were operating at the same 100 pounds pressure. A 3/8 inch nozzle will clean more than 3 times as much as a 1/4 inch nozzle and half again as much as a 5/16 inch nozzle. Here, it is the volume of air going through the nozzle that makes the difference. Adequate pressure and adequate nozzle size make for more production. To further illustrate the importance of the size nozzle being used, you're now seeing a comparison demonstration between a 3/8 inch, a 7/16 inch, and a 1/2 inch Venturi. In all cases, the identical equipment is being used and with the same nozzle pressures. Notice that the 3/8 inch nozzle does only 55% of the work of the 1/2 inch nozzle. The 7/16 nozzle does only 80% of the work of the 1/2 inch nozzle. Or if we were to compare between the 1/4 inch and the 1/2 inch nozzle, the 1/2 inch nozzle does 4 times the work of the 1/4 inch nozzle. Again, we repeat, work will be done in direct proportion to the volume and pressure of air passing through the nozzle. The test now being run shows a blasting comparison between 3 7/16 inch orifice nozzles. The one on the left is a straight barrel nozzle 3 inches long. The one in the middle is a 6-inch long straight barrel nozzle, and the one on the right is a 7 3/4 inch long Venturi shaped nozzle. Production attained by the Venturi nozzle clearly illustrates that whenever you have a tough cleaning job to do, the Venturi nozzles should be used. The short nozzles are fine if you're knocking off a light paint coating, cleaning aluminum parts, a brick or stone building, and so forth. Here you see a situation where using the identical volume and pressures of air, the same volume of abrasive, you're able to clean either 1/3 or 1/2 again as much with a Venturi nozzle as you could with a straight barrel nozzle. Of course, you can't always be sure that pressure at the nozzle is the same as it is at the compressor. The drop may be anywhere from 5 to 50 pounds, depending on all the elements in the system. It should be checked with a hypodermic pressure gauge. With the hypodermic needle inserted through the wall of the sandblast hose near the nozzle, the reading will tell you the actual working pressure at the nozzle. The fluctuating pressure indicated on the hypodermic gauge here is the effect of the load and unload cycle of a piston compressor. Don't be misled by gauges on the compressor or the sandblast machine. Rely only on the hypodermic gauge. The Pulsair gun is a special purpose accessory that is particularly good for tough cleaning jobs. It triples the outlet speed of the abrasive at the nozzle. Notice here that the measured area and pattern size being covered by the Pulsair gun is exactly twice as big as that being covered by the 5/16 nozzle. This means the average job takes half the time you might expect, and furthermore, it will blast off even the toughest bitumastic coating. As you can see, the blaster with the Pulsair gun has cleaned twice the area in less time. Among the other special purpose nozzles available, there is the 45-degree angle nozzle. The one orifice nozzle is designed to be used to reach hard to get at places. The 2 or 3 outlet angle nozzle is used in the internal cleaning of 2 to 6 inch tubing. There are several tools available for the internal cleaning of pipe. Illustrated here is a Tornoblast designed to clean from 1/2 inch to 7/8 inch ID tubing or pipe. These units will operate without the necessity of rotating the pipe or the tubing. Shown is a unit designed to clean from 1 inch to 2 inch ID pipe. In this case, and in the case of all of these tools, the abrasive blasts against the carbaloy diverter, throwing it at a 360-degree arc within the wall of the pipe. The basic unit will clean 2 inch to 3 inch ID. However, the same unit, when used with centering carriage, will clean up to 12 inch ID. These tools mean that piping or tubing can be cleaned in place without the necessity of removing them from installation. You can clean lengths up to 40 feet using either a pipe lance or sandblast hose. Here again is a model HB1, which with a combination of collars and buttons will clean the various sizes from 3 inches to 5 inches. Shown here is the same model with the large carriage for centering when cleaning from 5 inches to 12 inches. This is an easily adjustable expanding carriage. By loosening the lock nut, the carriage can be retracted or expanded with ease. This shot illustrates the material being thrown at the 360-degree arc within the pipe. Sometimes, dust from the surface being cleaned can get to be a problem. This is particularly true in masonry, building cleaning, or blasting an item such as a cement mixer. Here, the wet blast attachment is useful. As you can see, it is simple to attach and to use. It surrounds the air-driven abrasive with a curtain of water and holds the dust to a minimum. Another special purpose tool, the suction gun. Where there's a low volume of air available, the suction gun will prove effective and at the same time will raise very little dust. Tops for spot blasting, weld cleaning, inspection work. Now there's a nice piece of work. For complete elimination of dust, the Adductomatic is the answer. Here, the abrasive is held by vacuum within the confines of the machine and used over and over. It is particularly good for spot work and touch-up in confined areas. It is not a production tool, but is flexible in that it can be used overhead or on vertical surfaces. Notice, no flying abrasive or dust. The smallest direct pressure sandblasting machine made for production work is the Handy Blast. It is extremely useful for small jobs on an intermittent basis and will operate off a 2-horsepower compressor. Start or stop control right at the nozzle. You might call this a cabinet meeting. These are dry blast cabinets in various sizes for a variety of applications. Each has 2 armholes lined with rubber gloves for the operator's hands and a viewing window. In practice, the operator holds the object in the abrasive blast within the cabinet, observing through the window. Special conveyors, turntables, and multiple nozzles can be used in dry blast cabinets for automated operation. Dust collectors are attached. These are wet hone machines made to carry the abrasive in a stream of water. Depending on the mesh size of the abrasive, wet honing will result in any surface from rough finish to fine polish. Wet hone blasting machines are used in a great many industries. For example, aircraft, electronic, automotive, and tool and die manufacturing, and are proving particularly useful in finishing small parts, even with minute tolerances. We have presented here a wide variety of equipment used in sandblasting with one idea in mind: that high production is dependent on good equipment and on the speed that goes along with it. Given the equipment and the know-how to use it efficiently, your men will move fast and make profits